Alright, hi everybody. My name is Rahul Himal Shah, and this is my video summation of my of the take-home task given to me by Orchid. This is the database agent that I have created. Let's go ahead into the details. This is the GitHub repo that I'll be sharing, and that contains all the files and the information about how to set up this entire project. This is going to be the presentation walkthrough that I'm going through and what the contents of this video. Just a quick dive inside the tech stack. The Next.js is the front end that is shared with me already. For the backend, I chose Node.js, and the database layer I chose PostgreSQL, and I've used the result that is mentioned in the document for as the TypeScript ORM as well for SQL migrations, and then I've also used OpenAI's API with the GPT-4o mini model for being the LLM for this entire project. Having said that, this is what the project looks like as of now, and this is the database that I'm having. This is the database that's there, and as you can see, there are currently two tables which I have created, that is songs and Grammy, which I'll leave for now. Going back, my schema also is only for songs and Grammy as well. Now the Orchid's agent CLI is the CLI code. This is the main file for the entire project. This contains the entire script of how the agent is going to behave. It has multiple mini agents or many functions that happens in a stepwise manner. So in order to fire up the CLI, I'm going to use this command, and it's going to start the CLI. And this command line interface is going to start with asking you a question about what would you like to build. Let me run the second test case if so. Okay, so yeah, as we can see, perfect. All right, amazing. So it's going to ask me some confirmation messages about the new table it's creating, that's collections, and then I'm just going to confirm those, and it's going to go ahead with so it's an interactive CLI basically, where it's pushing all the data to the database. Alright, so for test case 2, it ran successfully. We have the new data which is there. I'm going to showcase it first on the UI. Why is it playing around? Okay, the UI, and this is where it is. So it created a new table known as show collections management, and it has also created the APIs as well. So with the help of the APIs, it's able to create a whole new section which has all the information, that is the discovery weekly and weekly discovery, release radar, all of this from both the tables. Let's get into what it has done. So once I give in the prompt, what can you do for me? Can you store the made for you and popular albums in table? It first things first, what it does is it goes through the user query, and this user query is passed to the OpenAI GPT 4.0 mini. It is responsible for parsing this query and identifying the entities. The entities over here are, for example, made for you and popular albums. With the help of the LLM and its training, it understands that these are maybe entities, and it's important for our own code base. So that's what it does by analyzing, and then it captures the user intent from the given query. Then it's responsible for firing up and checking the database state, that is what exactly are we having currently in the database. And it finds that there are two tables in the schema. I think those are the Grammy and the song tables that are there before, and only two tables were found in the schema as well. So it then scans the entire code base. This is very important because there's a command line interface which is responsible for this particular Spotify like application. It scans the entire code base with the help of various files in a folder of components. So for now, I've kept components as a focus, and it's going to check all the files that are there within this particular folder, and it's going to list the variable names that it has fetched so far, or that it's scanned so far. With the help of variable names, it's again going to use the LLM again. It's going to make a call by by creating a prompt. So it has actually identified the made for you as an entity, which is perfect. It's going to give this prompt that I've written, given the user made for you, given the user query made for you, which of these variable names, that is the ones that are extracted, most closely match, if not exactly, with the user user shared query. and it's going to say the LLM response for you is made for you. This is the variable name that's being used, and then the command line interface goes back to goes back to this path and fetches this particular variable, and it gets the entire data point. So at this stage, what we have right now is we the agent has checked the database. It knows the database connection is live. Then it knows the database connection is live over here. Then it has gone through the entire code base to find the relevant information, match that with what the user query is. We have found a particular path where the user query is as well, and then we have gone ahead and retrieved all of that data. With the help of all of this information, it goes ahead and decides to create a new table known as collections, and it confirms that from the user, and then it creates the collections table with 6 columns, and these 6 columns are these that are being listed over here. So it understands and it has the capability of creating this particular column, and we can see the same thing in schema as well. So now it has a collections which has 1 2 3 4 5 6 6 columns, and with the relevant schema. Moving ahead, next thing, so it pulls up the schema from the database, that is the newly created one, and it checks for the changes and applies them. One very interesting portion that I have included over here is the real columns check. So many a times what happens is it creates the schema with a set of column names, but when it's trying to push, the agent maybe hallucinates and matching with the column name. So this is where I've spent a lot of hours of engineering for this particular project. A couple of hours of engineering on this project, where I made sure that I have this real columns check in the Orchard's Agent CLI code. What this essentially does is that this loops through the columns that are there in the given table, and it then decides to list the column tables, and then it checks what the incoming data that it's going to feed in the column tables is going to be. Once it finds a particular match, then it's going to insert the data into the table, and once it's finished inserting the data into the table, it also shows that data is inserted into the table. And this is for the user query of I believe made for you album, right? Yeah. So now, since there were two entities into the user query within the same I can show that to you as well. So yeah, this is the user query made for you in popular albums. So within the same execution, it's going to pick up the second entity, popular albums, check the code base again. It's going to see that, oh, popular albums is okay, we have found that. It gets the response that the closest matching is popular album. It retrieves all the data from that, and then now it knows that there's already a collection tables with the same schema already existing, so it does not create, but it just says table collection already existing, skipping, and then it goes ahead and inserts the data, and it says data is inserted into a table. And then the next very crucial thing is it creates the API points, and then it creates the front end components as well. So we can see the API under API collections. This is the route. We have the get call, the post call, the put API, and the delete API. And also we can see the created front end components, which is nothing but the collections list over here, which is having the entire front end responsible for calling this API calls and showcasing them onto the UI that we have. And going back to the UI, this is what we have. It has all the CRUD functionalities. Like if I click refresh, you can see that in my terminal over here that we are getting a 200 call response in the body for a refresh, for a get click, and so on. So this is for that, and it also has all the capabilities like, for example, if I have to say edit this, and I'm going to keep this as say 100, and then I would save it. Okay, for some reason that didn't work. Say for example I added I'm right, I cannot change the ID, right? ID is something which is serialized, so I cannot change that. So let's say I'm going to change this to after seconds from hours, and then save it, and then we go back and see. It's a little messy, but yeah, we can see that for number 14 it's now from hours, it's changed to after seconds. And I can also go ahead and delete this if I want, and you can see that the 14 one is no longer there. I can delete something from other things as well, and I can add things also over here. So with the help of this feature, I can add things also. That's going to be the test case 2. um, so the test case 2 ran. Coming back to the test case 1 and see what happens. Okay, yeah, and I'm going to paste this and see. It should run, ideally speaking. I have done a lot of testing and it does create the schemas. There we go. Yeah, perfect. For this as well, let's see. Okay, yeah, so all of this is done, and it has created the necessary. So in the very same process, it identifies, it first parses the user prompt, it identifies the recently played songs. Now over here there's one more catch. The exact variable that we are having is not going to match the user query. It's like a synonym kind of a thing, or basically something similar, and that's why we have this LLM prompt, which is basically going to capture the semantic similarities between the given user prompt and also the given variables that we have. And if you can see closely, we have the variable name is recently played and the user prompt is recently played songs, both of which differ, but the LLM is successfully able to get the recently played correct variable retrieved. This is the kind of engineering that went through in the creation of this particular command line interface application. I was very particular about yeah, having a very generalized command line interface that is capable of doing handling multiple user prompts. And in the same way, it's going to create a table named recently played songs, and it's going to push the data and only the columns that are approved and unhallucinated columns, basically all the real columns. And then it creates the API endpoints for it, and it creates the front end components for it as well. So if we go back to the if you go back to the front end, we can see that show recently played songs management is going to have the files, the database is having and storing all of this information very well in its tables. And yeah, this is it, and we can have additions as well, like test, and then I can copy this test, test, and then test, and I can probably add this. It should, yeah. So this is how it's done. It's uh, able to add as well, and then I can edit it, and I can say testing, and then I can save that as well, and then it changes to testing, and I can delete it also, so it's gone. And all of this is also showcaseable in the PG admin that's over here. So if I go here to tables and if I refresh this, I'm going to see two more tables, that is increase from 2 to 4, having recently played songs and collections as well. And if I go to my tool and if I just do, or if I just run this, I'm going to have let's do it from collections. Yeah, so I have everything over here that I require, and anything that I do onto the site basically over here is going to be reflected over here, and anything I do over here is also going to be reflected over here with the help of refresh or just normal get calls. And coming to the other table, recently played songs. Okay, so recently played songs, and if I run this, yeah, we have that as well. So all of this is there, all of the data is there. The database was successfully able to do what it's able to do, what it was asked. Basically, the agent was able to create the table, populate it, also showcase the root like I showcased in the API column, API folder over here. It has collections for its root. There's a lot of testing tables, and then it also has a recently played root as well. So all of this is here, the delete, port, get, and post. So yeah, coming back, it is able to create the root to fetch information and from the table. I've also successfully implemented the bonus, that is the integrate the root back into the existing code so that the site can actually fetch the data and display it as well, which is what is happening over here. So for all the individual tables that it creates, this is just a basic UI, but it delivers the user it's very user friendly and delivers the data to the end user. Yeah, so this is the basic two test cases that was provided to me. These are some of the bonus test cases that please feel free to run this as well. It basically runs on some general queries like this, which is not related to anything in the code base as well. It can run some other bonus queries where I'm changing the database schema. So say for example I'm having some irrelevant database schema, and then I'm pushing in something structured like popular albums. It checks the incoming data with the database schema, and it understands that there is a mismatch, so it rectifies that particular table structure and schema, and it verifies with the user whether it's going to allow the user to basically truncate or delete the information that's not required. And then there's another bonus test case. It shows the robustness and user prompt versus schema matching with the help of the second LLM call that I'm doing, which basically says if you run something like this into the system, the command line interface, where we have highest in the room is a song in the songs table, but it does not have any space to take an address because of the secure SQL column matching, which eradicates hallucination over here. What this is going to be able to do is it's going to add the highest in the room as a song to the songs table, and it's not going to add in any address. So this is how I'm making the system much more reliable. I'm making it able to communicate well with the database, check what the database schema is, and then it's basically guarding the entire end-to-end database flow by making sure it's not putting in anything junk into the database. And yeah, just a couple of steps to increase the robustness of the entire application. So yeah, that's been my time, and that's been my CLI agent, the database agent that I would like to submit to you. Thank you for this opportunity, and I look forward to the next steps with Orchid in its hiring process. Thank you.